All right, so on page 7, we took just an itty-bitty little bit of notes about the reaction applications. So we're actually going to scroll down and start halfway down this page. This summary at the top of the page is actually a summary of the podcasts that was on pages 5 and 6, focusing on the types. But it's not a bad thing for you to see these types here before we talk about our applications, because our applications are almost like just different types. Remember, with each of these types of chemical reactions, we're focusing on how all of the atoms are moving around, whether they're breaking apart, coming together, replacing each other in our different reactions, or whether there's very specific ways that specific elements move and change in these reactions. So that's really just about kind of where they're going and what they're doing in terms of elements and compounds. Our applications of our chemical reactions are going to seem kind of similar, but something will always have a reaction and an application. And these are always going to be a little more focused on kind of what's changing about the atoms themselves. So as we go through these, I'll give you a little bit of a just kind of overview about what each of these special applications are, but we're going to focus on each of them kind of individually a little bit more in this unit, as well as in units 10 and 11. So let's go ahead and scroll down and take a closer look at all of those applications. So now that we can see all the rest of our page 7, you can see all 3 reaction applications. The first one is called reduction-oxidation reactions, but we will generally call it redox reactions. Just kind of takes the first bit of each of those words, reduction and oxidation, and puts them together. In these redox reactions, charges are going to change. And I know that you might not be able to tell that just by looking at them, but we're going to spend a lot more time with redox reactions later on in this unit. But we just need to be able to recognize them for right now. And the other 2 are called acid-base or precipitation reactions. So these are all 3 total applications. There's no more hiding anywhere. So it's a little bit simpler because it is only 3 of them instead of like the 5 reaction types that we've got. And this is even simpler because, as you can kind of see here, this redox reaction type, the only real information we've given you is that these 4 types of reaction, combustion, single replacement, decomposition, and synthesis, are all always redox reactions. So if you have any of these 4 types of reactions, then its application is automatically going to be redox. So 4 out of 5 times, it's going to be redox. So it's always a good guess. Now, the one type of reaction that we don't see here is double replacement. So I honestly like to start our notes here by actually physically writing, maybe drawing this line, sure, but I actually like to write down, this is all of our reactions except for our double replacement. So anything that's not double replacement, its application is automatically redox. So I would always recommend you start by finding your type, then the application. We're almost never going to ask you for the application without first asking you for the type. So go through that process, find it first, and then most of the time it's just going to be redox. Now, if it is a double replacement reaction, then you actually have to look at the reactions a little closer and see, is that double replacement reaction an acid-base reaction or precipitation? And in order to tell if something is acid-base, and I know it's written out here in words, but I'd really encourage you to write it down, we need an acid and a base to react together to be an acid-base reaction. I know, shocking. And as you should know, all of our acids start with H's. So I'm going to use this A here just to represent any other part of the acid, because this could be HCl, HBr, HNO3. All of those are acids. As long as you got something that starts with an H, then that's an acid. But we can't just find an acid-base reaction by finding an acid, because acids are in all different types of reactions, maybe even some of those redox reactions. To be an acid-base reaction, we need an acid, and we need to have a base there with it. And our kind of general formula, the way we can recognize bases in a chemical equation, is any kind of formula that ends with OH. So once again, my B here is just a placeholder. I don't expect it to actually be boron hydroxide. B could be aluminum or sodium or anything that can get with this hydroxide. Make sodium hydroxide, potassium hydroxide. All of those are bases. So in order to have an acid-base reaction, you need to be looking for the H's and OH's on your reactants. Those should be the only two things you have before our arrow in an acid-base reaction. So that's what you're looking for. But I do want to kind of show you this other stuff. We'll study acid-base reactions a little bit more, but one of the things you need to know about these acid-base reactions, because they are double replacement reactions, which remember I called the wife swap situation, because everyone is starting in a compound, but then the first two elements basically swap places, just like in that show Wife Swap. They switch it out just to create drama, but everyone starts in a nice happy family and couple, whatever, ends in a couple, everyone's got a buddy. So 2 compounds before the reaction, and we're going to have 2 compounds after. It's just that those separate pieces from those separate compounds are going to be getting together. So the first product that I could figure out I'm going to have, once my H comes over, switches places with the B to get with that OH, we could write as HOH, but more commonly, this substance would be written out with both of those H's together, and that O at the end, H2O, also known as water. Water is always going to be produced from an acid-base reaction because of how that H and OH are always going to be getting together because of the double replacement reaction. The other thing that we're going to make is some kind of salt. And I'm just going to write Ba here because the salt will be made from those leftover pieces of the whatever was with my OH in that base and whatever was with the H in my acid. So those A and B pieces are just going to come together to make some kind of ionic compound. And the generic term for ionic compound is a salt. So it might not be table salt, something that you could eat, but all acid-base reactions make salt water, essentially. So keep an eye out for an acid and a base to find those acid-base reactions. Precipitation reactions, you also have to look at some of those little details in these double replacement reactions. Here, though, it doesn't really matter what we've got. I'm just putting these little blanks here to represent any of our chemicals, whatever they are. What's most important here is the states of matter. And as you can see written out, a precipitation reaction is when we have aqueous, meaning water-based, dissolved in water, reactants, and they form an insoluble solid as a product. So when you're looking at a reaction, you're going to have to see those states of matter written in the reaction to tell if it's precipitation or not. And you need to be looking for these AQs. You have to start with 2 AQ things before that reaction. They're going to be compounds, but look for AQ before the arrow, and then a solid after the arrow. It could be on that first substance, it could be the second substance, as long as something in that reaction is a solid. Then, after that arrow, we're producing a solid from these 2 aqueous things, then that is precipitation. It doesn't really matter what that other substance is, whatever is not the solid. We know we're going to make 2 things here, so there is going to be something else here, but it doesn't matter for finding precipitation. That could be a solid, liquid, gas, aqueous, whatever. It's probably most of the time going to be aqueous, but don't count on that and don't focus on that part. What we're looking for, I'm going to put this back here where it came from, is that AQ, and then some kind of solid after that arrow. If you see that, then that's a precipitation reaction. And specifically, that solid that is formed is the precipitate that we made. So those are our applications. Find the type first. 4 times out of 5, we're just going to be saying redox is the application. That's a lot of it. But if it's double replacement, we have to look a little closer at what kind of double replacement it is, what application it has. So hopefully that's not too bad and it helped you get caught up.